Hello, hello, hello. Am I audible or not? Let me just quickly check that. Lighting is a little bit low. Not good. I guess it's all right now. Let's just start the stream. Uh, Wait a second. I think it's all right now. So let's start the stream. And we have taken 2 days of break from the stream, and now we will be again beginning with full pace. And I promise we will not have any breaks this time. There can be exceptions, but so let's just start the stream. We are on arrays. We will now study about arrays. Today I have decided to cover up 3 topics. I hope I will cover them all, but only if I will be moving a little bit fast. But I guess 2 topics should be covered today. So the 3 topics are arrays, functions, and structures. 3 individual topics, but all 3 are dependent on each other. So let's just start the topic without further delays. I hope my sound is all right. Okay, sound is absolutely good. So let's just start the topic. Arrays is a very important topic as we talk about in any programming language when we talk about data structures. So it is an important concept. So the C language, we will start with the chapter 7, working with arrays. And today I have inverted the book. I have inverted the colors of the book so that it's easily readable. Okay, hi Afifa. So the C language provides a capability that enables you to define a set of ordered data items known as array. So array, as they have defined, they are they are defined as set of ordered data items. So data can be of any type, I guess. So this chapter describes how array can be defined and manipulated. Okay, so we have defined, but we can manipulate the array also. For example, we can edit the items inside, we can delete it, add it, anything. So in later chapters you learn more about arrays to illustrate how well they work together with program functions, structure, character strings, pointers. As I have told you that all topics are individual but are interlinked, and the previous topics will be needed in today's class. All the topics that we have covered till now will be needed in today's lecture. So suppose you have a set of grades that you want to read into the computer, and suppose that you want to perform some operations on these grades, such as rank them in the ascending order, compute their average. Okay, so we want to take input of multiple data. So every time you cannot simply do that, like printf enter grade 1, then scanf, then again, like if there are 100 records, so you cannot just write like this. So for that we have arrays. So therefore, using the techniques described previously, you would read in each grade and store it in a into a unique variable, perhaps with a sequence of statements. So you need a different variable every time. For example, if there are student records, so student 1, student 2, student 3, and so on. So after the grades have been entered, you can then proceed to rank them. This can be done by setting up a series of if statements to compare each of the value to determine the smallest grade. Okay, so it's a bit long procedure. It's a bit long procedure. So these are the you can say disadvantage of you can say it is the advantages of array. So they have just find the loopholes in the C programming that arrays can make up. So defining an array, how you can define an array? So you can define a variable called grades. Okay, you can define it by grades or taking a variable. So not particular like grade 1, grade 2, a specific term, grades. So which represent not a single value as I have told. So but an entire set of grades. So multiple set of grades. So each element of the set can then be referred. For example, if a student having 10 subjects and we have to display all the grades of each and every subject, so you cannot just take 10 different variables every time. So what you can do instead, you can just define grade as an array, and you can store 10 you can grade as a set, and you can just enter the 10 grades in it, or store the 10 grades in it. Okay, so each element of the set can then be referred by the means of a number called index number. Okay, so each element is addressed by an index number or a subscript. So where in mathematics a subscripted variable x refer to the ith element x in a set, and c the equivalent notation is as follows. Okay, so this is the way of writing. So I think I is the number of total number of things or the data present in the array. So x is the array, so we can just define the expression like this: grades and 5. So 5 is the, I think 5 is the number of data entries. So reads as grades sub 5. Sub 5 means subscript as 5. So refers to the element numbers 5 in the array called grades. So elements begin with the number 0. So so index number start with 0. So if it is defined as grades 5, so it will be like something 6 elements. So actually refers to the first element of the array. For this reason, it is easier to think. So the first element of the array is grade 0. Okay, so an individual array element can be used anywhere that a normal variable can be used. For example, you can assign an array value to another variable with a statement such as following. So g is equals to, we have taken a variable, then defined an array grades 50. Let's just wait for 1 minute. Okay, I think this stream is working absolutely fine now. All right, I have to sit like this or this. Okay, so okay, let's resume our topic. So we have defined array. So the statement takes the value contained in the grades 50 and assign it to g. More generally, if I is declared to be an integer variable, the statement g is grades I. So takes the value contained in element number I of the grades. Okay, so I is the element number of the grades array. Grades is the array, and assign it to a g. So g is the assigning thing. So we have assigned these thing to a particular variable. So if I is equals to 7, when preceding statement is executed, the value of the grade 7 is assigned to g. Okay. So what we can do, we can just assign a variable to any value present in an array. For example, if the value of I is 7, so the this means the value of grade 7 is assigned. Okay, so value of grade 7 is assigned to the variable g, not as a whole. Not all the array as a whole is defined by a single variable. So a value uh, can be stored in an element of an array simply by specifying the array element on the left side of an equal sign in the statement. Okay. So if you want to uh, just give a value to a particular index number in an array, you can just write like this. So the value 95 is stored in element number 100 of the grades array. So the statement this has the effect of storing the value. Okay, here we are assigning the value and here we are storing the value in a particular variable. So this is like it works. So has the effect of storing. So the capability to represent a collection of related data items by a single array enables you to develop concise and efficient programs. For example, you can easily sequence through the elements in the array by varying the value of the variable that is used as subscript array. So the for loop, like this is the for loop. So we have defined that we have an initialized I with 0. I will be going to the number 100 and it will be iterating one by one. So the sum will be stored. So sum is equals to sum plus grade. Okay, so every subject is stored. Like 100 subjects are present. Like it's not practically possible 100 subjects, but if the 100 subjects are present and we need to calculate the sum, we can just do like this. So when the for okay, so sequence through where we have left. So for the for loop, sequence through the first 100 elements of the array's grid, element 0 through 99, and adds the value of each grid into sum. So when the for loop is finished, the variable sum then contains the total of the first 100 values of the grid's array. Assuming sum was set to 0, okay, so we will set this sum to 0, so it will not take any random value, or C programming just not randomly assign anything to sum. So we will initialize sum also at the beginning of the program with 0. So when working with arrays, remember that the first element of an array is indexed by 0. Okay, so first element is 0, indexed by 0, not particularly 0. So the last element is indexed by the number of elements in the array minus 1. Okay, so if there are 8 elements and you want to access the last element, so let's just use a whiteboard if possible. So let's assume a array here, and let's take 4 elements, 1, 2, 3, 4, 5. Let's take 5 elements. So any random value, 2, 4. Let's take a set of even numbers, and we will be starting the set of even numbers from 2. So if you count the number of elements, it is 1, 2, 3, 4, 5. And if you do the indexing of these numbers, it will be starting from 0. So 0, 1, 2, 3, 4. So in order to access the last element, and if you want to just store the value of the last element in a particular variable, let's say g, so what you will do, so let's name this array as arr. So this is an array arr, and you want to store the last value, and you know the total number of elements inside the array is 5. So if you want to access the last value, it will be the total number of elements minus 1. Marco Patro, what happened, brother? Why you sad? So if you want to access the last element, you will be just doing the total number of elements minus 1. Hello, hello, hello. Why are you from two channels? Marco Patro, Patro Gaming. Are these two different channels? So it will be represented as ARR, and the last element, if you want to access, it will be total number of elements minus 1. So 5 minus 1 is 4. So it will be automatically assigning the value to 10. So this is how it will work. So in addition to integer constants, integer valued expression can also be hi brother, hi, hi. Okay. So can also be inside the brackets to reference a particular element of an array. So if low and high are defined as integer variables, the statement next value is equals to stored value. Okay. Low plus high upon 2. So particular elements. Okay. So assign the value index to the variable next value by evaluating the expression low plus high by 2. Okay, so if low is equals to 1 and high equals to 9, and the value of stored data 5 by 2, so is also referring, because you know that an integer division of 11 by 2 gives the result 5. Okay, So if you want to access the middle element, so what you can do, you can define, since it is an integer, and if you divide by 2, if you divide any odd number by 2, it will be just round off to the nearest number. Like if it is 6.7, it will be to the lowest preceding value. Like if it is 6.7, it will be allocated as 6. So this is how it works if you want to access the middle value of an array. So just as with variables, array must be declared before they are used. The declaration of an array involves declaring the type of element that will be contained in the array. So in case of variable, we have defined like int, float, and char, and also like in array, because it is a set of data, so we want to specify what data we are working with. So as well as maximum numbers of element that will be stored inside the array. The C compiler needs this later information to determine how much of its memory saves to reserve for a particular array. So as an example, the declaration int grade 100, so integer, so no working with decimals. So declare grades to an array contain 100 integer elements. Valid refers to this. Array can be made by using subscripts from 0 to 99. So total number of elements that are present here is 100, and the it will be indexed as 0 to 99. But be careful to use valid subscript, because C does not do any checking of array bounds for you. So a reference to element number 150 of array as previously declared does not necessarily cause an error, but does not most likely cause unwanted, if not unpredictable, program results to declare an array called average that contains 200 floating point array. The declarations. Okay, so if you have not, if you want to access the element that you have not declared, like you have declared the or allocated or asked C programming to give you space for around 100 integers that are stored in array, and you want to access the number 150, it will not be possible, although it will not throw error, but it will not work. So to declare an array called average that contains 200 floating point, the declaration is like float averages, and there are 200 points. So is used. This declaration causes through space inside the computer's memory to be reserved to contain 200 floating point numbers. Similarly, the declaration int value 10 reserved to space for an array called values that could hold up to 10 integers. So the data size, if you would talk about data size of float and integer, it's different. So we have already seen in the data types chapter that how the memory is allocated and how much memory a float contains and how much memory int needs to be stored. So this is how it works. So they have taken a similar example to specify how they are working. So there, if you want to know the number of elements, so you can just go to the last element and just 2 plus 1, and you can get the total number of elements present in an array. So the elements of an array declared to be type int, float, or char can be manipulated in the same fashion as ordinary variables. You can assign values to them, display their values, add to them, subtract from them, and so on. So if the following statements appear in a program, that the array values would contain the number as shown in figure 7.2. Okay. Okay, so this is how I think they have specified some kind of numbers. Okay, so this is how they work. Okay, so you can do addition, multiplication, and so on, and you can access individual value to store it in a particular you can say at index number. So if you see the index number 3 or the position 4, because first, second, third, fourth, the value 3, index 3 has position 4. If you see at position 4, it is like value 0 plus value 5, so value 0, and I think they have defined it as 197 and value 5. So the addition of this number 197 and 350 will be assigned at the position 3, that is 347. Okay, so the first assignment statement for the effect of the storing value 197 is the value 0. Okay, so the first element and indexed at 0. So it's similar fashion. The second and the third assignment statement store minus 100 and 350. So you can also store negative numbers if you are working with integers. So it should not be like decimal values, but you can go behind the number line before 0. So the next statement which adds the content of value 0, which is 197, to the content I have already told. Here they have done another operation, like they first store the value of 5, then divided the value of 5 by 10. So the value of 5 is 350, so 350 by 10 is 35. So you can just do random arithmetic operations with the values. So the preceding program statement are incorporated in program 7.1. The for loop sequence through each element of the array displaying it's okay. Working with array, okay. So they are, I guess, if you don't assign anything to the particular index number or position, it will be taken as 0. So let's just try to create this program. We will do micro arr.c array.c. We will be first. So let's just take this from here till here. Paste selection. So header file and naming the program. So let's just start the program. Firstly, we will declare the array webcam. Webcam. What happened to webcam? Okay. Thank you. I think it is switched off. Nice. Please give me 1 minute. Thank you for telling. I forgot to connect the charger. Okay, so let's just continue with the program. It will be connected soon. So firstly, we will be declaring that we are using array known as value, and the number of elements we are going to store in this is, let's say they have taken 10. Okay, so we will take 10. We can take 100, we can take 200,000, anything, depending on the memory you have. So we have taken 10 here, and they have taken another value, like they have taken another variable index. So you can take it as I, and you can just define it here only. No need to go separately. Why it's not charging? So we have declared everything that we need to use in the program. So now they are, let's take one more thing. Let's do one more thing. In order to short the program, we will take value as v. Now we can easily define. So v, okay, so v1. So we will take our own example. Let's assign v1 to be 100. Let's take v3 to be, uh, let's, can we do arithmetic operation here, like 190 minus 90? So we have 10 elements. Okay, so let's take v5 as a negative number. Okay, nice. Negative number like minus 90, or okay, so let's take another number, or another, let's assign another value to v8, and now we will be doing arithmetic from by accessing the elements from the array, like v1 plus minus v. We have not declared anything in v2. Let's take v2 because it is 0, so it should be like v1. And okay, so now we will be running a for loop in order to store everything that we have assigned. So for because we have taken I, so we will be initializing I with 0 I, and we will be taking, like, because since we have taken 10, so it will be going to 10. Okay, 10. And let's, because we want to access each element, access each index number, so we'll be iterating the value, and let's just begin the for loop. Okay, so printf, because we need to print each and every element, so the value, uh, because we need to specify each and every value, we'll be doing since it is an integer, we will be use a format specifier like %d, or we can use %i also, but we will use %d. And because we are assigning the value, so before that we will do equals to, and separated by comma, we will be defining as %i, because %d, because we want to display each and every value, and we will be ending that with a new line character in order to get a in a structured way. And after that, okay, so one thing okay, I think inverted comma will be here because we are accessing each and every element. and now we are declaring the variables. So like we have declared I, and we have declared the variable and with the index number I, like this. So we have I, we have this, and let's just terminate this, and no need to return 0. It will be done like this. So let me just start my webcam again. Try to start my webcam. Now it's working, I guess. It's not. It's not working, I guess. Let me just charge the webcam a little bit, because it's not charging. It's only 2%. Okay, so we are in the program. Let's just print the output. And I think I have done one more mistake here. We have to terminate with semicolons. Okay, so we have initiated, we have done the value. So those values we have, those index number that we have not defined any value, it will be 0. So I guess let's see the output, how it is working now. Okay, so control SQ, and let's do GCC ARR, and writing the output to ARR, hit enter. So unexpected declaration, I think we have done mess up with the brackets. Okay, yes, we have to add one more bracket, and let's just save it, continue GCC ARR, and we will try to run this now. Okay, so we have got the values, and let me just show you one more thing. Micro ARR dot C. So we have assigned the value to 1, index number 1. We have not done anything with index number 0, so it is 0. We have assigned the value to 1, like 100, it is 100. We have skipped 2, then the value of 3 is 190 minus 90, that is again 100. Value 4, we have not taken anything. Value 5 is minus 90. Okay, it's working fine. We have not done anything with value 6, but it has taken a random number. Let's just try to see why it happens. It should be 0, but in this case, so variable, let me just see if there are any exception with that. So the variable index assume the value 0 through 9 as the last valid subscript of an array is always 1 less than the number of elements due to that 0th element, because you never assigned values to the 5 of elements in the array, element 1, 4, and 6 through 8. The values that are displayed for them are meaningless. Okay, so it's not necessary that this value should be 0. It will be meaningless value. Even though programs output show these values at 0, the value of any unutilized variable of array is not defined. For this reason, no assumption should never be made as to the value of. Okay, so if the index number is unutilized, or unutilized or uninitialized, so what this will do, what the compiler will do, it will assign a random garbage value. So this is a garbage value, you can say. Okay, so these are meaningless, but you can see some of the values are also 0. Like we have done v8, v1 minus v2 should be 100, and okay, it should be 100, it is 100. I think it's working quite fine. Let's just try to change the value of v6, and v6, let's take it as 099, and let's terminate this. Will it will be 99 or 099? Let's see. Control SQ, compile this. Okay, so yes, we cannot initiate anything with 0 cause invalid digit 9 in the octal constant. Yes, because in the data types chapter I have told you one thing, that because we are using format specifier as %i, and they are used for integers, but in the case of integers they can be decimal values, they can be not decimal, we can say to the base of 2, or to the base of 10, to the base of 8 or 16, right? Like 8 it is octal. So we have seen in the octal data types, in the integer data types, in octal, specifically octal, we have seen that it is beginning with 0. That is why I've taken this example, because anything we are beginning with 0, it is be treated as octal, and we have to use %o there for printing the value of octal. So let's just correct this once. If I do x here, so it will what it will do, let's see. Control S Q, and if we try to just do this, so it will show hexadecimal now. It is taken as undeclared variable. It is now it is taken as variable, but we have seen that if you are initiating something like with x, so it will be treated as hexadecimal. But in the in this case it is just identifying 0 as octal constant, but in this case it is treating this x99 as undeclared variable. Okay, so micro arrc, if we do 99 divide by 8, since it is an integer, it will do round off. Let's just try to compile this and run this first. Okay, so value of, we have defined the value of which number we have defined for 6, I guess, but it has again taken a random number. Let's see why it happens. Is it not saved or what? It is saved, but 99 divided by 8, 8 ones are 8, and it's 12 something. 12 8s are 96, so it should be 12. But have I compiled the program? Let me just again see it and try to run this ARR. Okay, it is again taken. It is taken now minus value. Am I doing something wrong with the output value? Output. We have compiled and stored it in array. Let's just do one thing. Let's just assign it a particular value. Value 6 as 99. Right. I think it doesn't matter what is the order you are assigning, because 0 to 5, then they have defined 3. So let's just try to do like this. Control SQ, compile this, run as ARR. Again, it is taking a random value. Why? Why? Let me just do cat, and what was the name of the program? Array.c. So okay, I think I have used double is equals to, that is why it is making a problem. I'm comparing the strings. Okay, so I think I have got the problem here. Control SQ, we will be again compiling this ARR. Okay, now the values again, so let's try to divide by 8. So the syntax was wrong, that is why it is treating it as a garbage value. Let's run it again, and this time it is 12, because since it is an integer, it will be do round off. So let's just take a 2 minutes break till I have uh, just try to set up my webcam. Please, please, it should work now. Okay, it's working, but okay, now fine. I guess my webcam is visible now, and we move forward. So we have seen this program, and we have also seen how garbage values are assigned. So they have taken another case, like they have leave it blank. So in this case, it is okay. Random values assigned, I guess. No. So value 9 is not blank. It is value 5 by 10. Okay, okay, no problem. So they have done one more thing. They have used a decrement or post decrement operator, you can say. So it is just decrementing the value. So minus 100 minus 1 will be minus 101. And yes, it's minus 101. So let's just move forward. So the variable index assumes the value 0 through 9 as the last valid subscript of an array. So is always one less than the number of elements due to the zeroth element. So they are telling the same thing, that uh, still they are, I guess they have taken 10 values, but the last value will be assigned as 9 because there exists a zeroth element here. Okay, so if you want to access the last element, you can just do one thing. You can take the total number of elements present in the array and do minus 1. So you will easily get the last element. So using array elements as counters. So it's now time to consider slightly more practical examples. So suppose you took a telephone survey to discover how people felt about a particular television show. So let me just connect arrays a bit with cybersecurity, as we are just targeting cybersecurity. So as particular, if we talk about array and the use, it's a kind of notorious use in cybersecurity, particularly in ethical hacking or penetration testing. So you have taken seen the case of OTP generation. You know OTP generation, how it happens. And so what other languages do you know? So I know C, I know Python, I know, if you ever heard about R language, and I know Ruby a little bit. Bash scripting, you consider it as language or thing? I don't know. I know JavaScript. HTML, CSS, I don't consider it as languages. But main languages that will be used in cybersecurity is Python, C. I know assembly. How I skipped that? Assembly, ARM64 or x86, both, and bus. That is. So we are talking about the notorious use of arrays in cybersecurity. So you have seen the OTP generation thing. So if the platform in which you are entering the OTP is not secure, you can do a OTP bypass attack or OTP brute force attack by simply creating a bash script. And in bash script, there are also arrays, data are also defined, data structures, you can say. Array also present in bash. You can create programs that can handle array. And for the OTP okay, that's great, keep it up. Okay, so for OTP generation or bypassing the OTP, if the platform that you are using in order to enter the OTP, it does not has a bypass filter or restriction or session timeout, uh, you know that there are this is a 4-digit OTP or 6-digit OTP, so you can create a multiple uh, combinations of numbers, 4-digit numbers. You can store it in an array, and you can just attack the anything that the system is not secure. But I should suggest that you should do that in a controlled environment, and you should not test public domains. Just a feedback, just a suggestion. So using array elements as counters. So it's now time to consider a slightly more practical example. Suppose you take a telephone survey to discover how people felt. Okay, my webcam is working or not. Okay, it's working fine. So now you want to analyze the results. One of the first pieces of data you want to gather is a table showing the distribution of the ratings. Other words, you want to know how many people rated the show. Okay, after this session, I am also planning to discuss the future of streams that we will be doing, because I have taken another article, or you can say another textbook of C programming. It is an advanced C programming or C++ programming in cryptography. So you will be dealing with lot of ciphers and all, but I thought it's a bit advanced. You should be knowing, firstly, you should be knowing the basics of cryptography and basics of penetration testing, because at the initial stage, you will not get encrypted systems to crack the password with cryptography, and you should not be making any C scripts for ciphers and to create a script for cracking passwords. So that is why I was planning that after C programming, we should be shifting our way to are way more aligned to the prep of OSCP and uh, much to penetration testing, particularly red teaming. So we will be dealing with each and every branch of red teaming, but firstly, particularly with penetration testing. Okay, so although not an impossible core, it would be a bit. Okay, I think I've skipped something. Okay, so they are talking about 5,000 members detail. Okay, no problem. So count the number of response in each rating category. Okay, so I think for storing the values, not like if you want to store 5,000 values, you will not like doing this value 2, value 3 and all. So for that, you will be again using a loop, and this time, yes, they are doing the same thing. So you can set up an array of counters called rating counters, for example, and then you can increment the corresponding counter as each response is entered. So to conserve space in this book, program 7.2 assumes you are dealing with 20 responses. In addition, it's always good practice to first get a program working on a small test case before. So they have taken example of 20, but they are saying that they will be working with smaller test case. So they have taken 11. Pretty good. So they have taken the space as 11, but the last element would be 10. So it will be like this. So you can either write like this, or it should be like smaller than 11. So it will not access the 11th element, but it will stop at 10. Or you can write like this. Pretty basic. So let's just make this program. We will edit the same program, micro arr.c, and till this it is same. Okay, okay, completely fine. So here they have taken 11 values. Let's take 11 because we are working with 10 records, and I index same I. So first thing first, what they are doing, demonstrating an array of counters. So in addition, it's always good practice, okay, proceeding with the full set of data because problems. Okay, so they have not defined what they are doing. Let me just quickly see what they are doing. I think enter your response, bad response 15, rating, number of response. Okay, so they have defined an array in which total elements are 11, 0 to 10, and I for indexing response to count the number of response, I guess. So printf, enter your response, started with I, continued to 20, plus I, scanf. They are storing the response here, and if the response is okay, it should be within the range of 1 to 10, excluding 1 and 10. So it will be printing bad response, else plus rating counters and response. Okay. Okay, so if a bad response is encountered, it will be, I think it will be ending the loop or something. Bad response, yes, it will be ending the loop. And else what it will be doing, it will be doing like again and again printing the or taking the number of response or taking the response. Pretty good what they have done here. Percent 4i, percent 14i. I think we are not dealing with float. Why they have specified 4 and 14? Let me just see first. 4%, they have not said anything about this, but I have understood the program. Let's just create our own program here. We will be needing one more variable, that is, let's take res response, and let's try to create a program. So we will be starting with for loop, and again we will be initializing with 0. We'll be going till 11. uh, we can do like this, or we can also do like this. So let's do like this. Okay, so again argument 3, we are incrementing the value I plus plus. We are just beginning the for loop, and now what we need to do, so first we need to set the first element as 0. So because they have taken rating counters, we will take vi as 0. First vi as 0. Nice. Okay, so now we have set the value of element to 0. Now we'll be printing inside the loop that printf enter the value or enter your response. So enter your response, and let's neglect with this new line character ending with this. I think again we are making a loop here. Is it like loop inside loop, or we are just they have not said anything. Printf should not be come inside a loop, because it will be printing again and again till 10, and we just need to implement the loop for every value. We are just setting the every value to 0. So let's just create another loop here for I is equals to 0. So we are taking 20 response. So firstly we'll be initializing with 20, then we will be giving a interruption statement like I should be less than 20 or equal to 20. Okay, it will be taken as equal, less than equal to 20, and we are just incrementing the value and just beginning the for loop here. What we will do now, uh, we have already told the user that you have to print a response. Now we want to store it in the array, so we'll use scanf. uh, Scanf, since it is an integer, we will be using format specifier as %d or %i, anything you want. Let's use %i this time, and we will be storing the value and uh, to response. Okay, so we'll be storing that in response because we need to know what's the response, and we need to terminate it. Uh, Terminate it with when the value is out of the range. So now we will be running a decision making statement like if the response, so they have taken two cases. It should be not, it should be greater than 1, not 1. It should be less than 10, not 10 exactly. So okay, so let's do one thing. It should not be negative, it should be any positive numbers. So response res should be greater okay, should be greater than 0. It should not be 0, it should be positive every time. So what you will do, printf uh, we are specifying that result should be greater than 0. Okay, so I think they are taken every negative because we are telling that if the result is negative, we are printing bad response, and we are telling that what's the response. And in else block, what we will do, we'll be just increasing the v, and I guess I have messed up one thing because we need the response inside the array. So what we will do now, in the v we will be storing the response. Okay, so they have taken the rating counters. So this was the array. Rating counters initialized at 0. We have assigned vi as 0. And now we want to increment the value of responses inside the array. Okay, pretty cool. So now I think we have out of the for loop, we'll be printing printf in order to just do systematic things. New line character, rating, and tab space, number of response. Okay, again neglecting with the new line character. So I just copy this thing because they are making it as a structure or something. Copy, paste here. Okay, so now what we will be doing, we will be printing the array elements. So print I, or sorry, we will be running a for loop for we will be initializing with I is equals to 0. So there are 10 response. So there are 10 elements. So I, it will be going till 10. So I should be less than is equals to 10, incrementing the value, and you will be printing the arrays. So they have okay, percent. We will do one thing, %d, and they have printing the index number, and they have printed the array. So our array is v, and it is stored as response here. Okay, they have taken as I. Okay, okay, no problem, I, and terminating it with this, setting the system state to 0, return 0. Okay, I think there should not be any problem now. Okay, this is working fine, this is working fine. Okay, what's the starting? Where is the starting? IRES. Okay, it should not, it should work now. Control SQ, GCC error. Okay, okay, no error. Error. Enter your response. 2, 3, 5. So we cannot enter. Okay, blank output it is also taking 4. So I think 10 response we can do. 1. So 4, 5. So 4, 3, 7, 8 we have done. 4, 5, 6, 6, 7, 8. Okay, I think it will be going till 20. Okay, segmentation fault. Okay, so I think we are done with 20 values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So as we have entered the 21st value, it's showing error. Okay, so because the loop is, so it should work now. Let's do this again. Again, entering the random numbers. Hello, sir. Hello. And if we do -3, bad response. Rating and number of response. GCCR.c. Okay, it's working fine, but I have not used the new line character. That is why the output is like this. It should be like this because as I have used a, if I use a new line character, it will be like this. But I have not used a new line character, so it is printed in the same line like this. Okay, no problem. Hardik CPQ9A. Hello, hello, brother. So the array rating course is defined to contain 11 elements. A valid question you might ask is, if there are 10 possible responses to the survey, why is the array defined to contain 11 elements rather than 10? So the answer lies to the strategy for continuing the response in each particular rating category, because each response can be a number from 1 to 10. Okay, number of responses. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10th, then 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So I think they have counted the number of, okay, so they are counting the numbers. That is why they have defined it a particular range, and I have given a given the condition to take only positive values. That is why the problem is coming. Hmm. Okay, no problem. So the program keeps track of the response for any particular rating by simply incrementing the corresponding array elements after first checking to the make the certain that the user entered a valid response between 1 to 10. For example, if a rating of 5 is typed and the value of rating course is 5, so is incremented by 1. Okay, so that is why we are taking the response 1 to 10. That is why we have mentioned the size of array to 11. वर्मा जी कंसिस्टेंसी ही कहते हैं. कहाँ consistency? We have taken 2 days break. Verma ji, are you new to the stream? So let's just move. We have seen the reason why we have taken. Okay, so as a point of discussion, you could have developed your program to use an array containing precisely 10 elements. Then when each response was keyed it by user, so you could have instead incremented rating course response minus 1 this way. So rating counter 0 would have contained the number of responders. Okay, कितने वर्मा को जानते हो? Uh, there are a lot, but I can't say. If you are that Verma, okay, I think you have got the link from LinkedIn. I know you who you are. Thank you for the coming to the stream. So, as a point of discussion, you could have developed your program to use an array containing precisely 10 elements. So, then when each response was keyed in by the user, you could have instead incremented rating course. So, since we have taken 11, so number of responses as 11 and 11 minus 1 is 10. So, that is why the rating is going from 1 to 10. Okay, pretty good. अरे आप तो सर स्पेशल है. So this way, rating counter 0 would have contained the number of respondents who rated the show as 1. So rating counter 1, the number who rated the show as 2, and so on. So this is okay. So they are counting the number of responses. So I guess if counting the number of responses, the each number have printed how many times by the user. So occurrence of number they are counting. For example, 6 is here, 6 is here again, 3 6s are there. So yes, they are counting the occurrence of the numbers entered by the user. Share me your stream link on WhatsApp. Okay, someone. What's your full name? What's your full name? I think I'm assuming you as a wrong person. Study program 7.3, which generates a table for the 15 Fibonacci series. Try to predict its output. What relationship exists between each number of the table? Okay. We are generating a Fibonacci series. Uh, Again, that thing, I think I have to use a whiteboard here. So Fibonacci series will be starting with 0, then 1, and again adding these 1, then 1 1 2, 1, 2 is 3, 2, 3 is 5, addition with the previous number 3, 5 is 8, and then again addition with the previous number, that is 13. So you can say this number, or like I is first set to 0, so I plus 2 is equals to I plus 1 plus I. You can say like that. I think this is the concept they have used here. So Fibonacci I is I minus 2. Okay, so they are doing like this. So I is I minus 2. Okay, so they are accessing this number first and this number first. Okay, no problem. You can do like this, I plus 2 minus I, or you can do like this, I minus 2 plus I minus 1. So if you want to know the value of the second index number or the third position, so it will be like the first position, like Fibonacci 0, the index 0, plus the first position, like Fibonacci 1. Or sorry, the second position, index number 1, Fibonacci 1. Okay. I think they are printing the Fibonacci number up to 15. Yes. Let's create this program up to 10. ls micro fib.c. Okay. So we'll be taking this from here. Paste clipboard. Okay. Header file, naming the program, passing void argument. Let's just start. So int, we will take fib and we will be going till 10. Okay, so index number is I and terminating. Now what we will do, we have to define, we have to tell the compiler that we are defining the two values like 0 and 1. By the way, I am regular in our streams. Okay, what's your name? What's your full name? I will be, what's your first name यार? Last name तो पता चल गया, first name क्या है, मैं थोड़ा सा दिमाग में आएगा मेरे को. ऐसे तो मैं पता नहीं किसको assume कर लूँगा यार. So int fib I 100. Okay, so fib, we need to specify the 0th and the first index number. So fib 0 is 0. We know that the Fibonacci series begins 0. Then fib 1 will be beginning because it's the 1. And now we want to add these and store it to the second element. So I have told you the concept how it is done. Let's try to run a loop here. So for I, we will not be starting with 0 because we have already denoted, or as the told that compiler that Fibonacci 0 index, and for first index we have already told the value, assigned the value. So now we will be beginning from 2 and we will be going till 10 because, okay, so let's go till 10. Not is equals to, because the size is 10, so last element will be accessed is 9. So up to 10 or before 9, before 10, sorry. So that time x guy. Okay, 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 okay. Cool, cool, cool. No problem. I have assumed you as a wrong person. So I plus plus. Now, now I got to know who you are. So we are incrementing the value. We are storing it. Now we will writing the concept of Fibonacci. That like fib I is equals to the sum of the previous two elements. So fib I and the sum of previous two, like fib I minus 2, I minus 2 plus fib I minus 1. Okay, so we have defined how this will work. So next what we will doing, we are again printing a loop here. Let's just not use bracket here. And again we are using a loop in order to print all the things that we have, because now we need to initialize with 0 because we are printing the values from 0. So I0 till I is less than 10 or matlab till 9. So why it is not, shift is not working. Okay, and now we are incrementing the value, so we'll be using I plus plus, and now we'll be printing. So printf. So because since it is an integer, we will be using format specifier %d or %i, your choice, and as fib I. Array is defined in square brackets, so let's just terminate this printf. Okay, pretty good. And we need to print that bracket is closed or not. No, close the bracket, control s, control q, gcc fib.c, writing the output to fib, hit enter. Okay, it's compiled. Fib. Okay, so I think it is going in single line 0 1 2 3 5 8, then 13 21, then 34. So we want to print that in a new line, so let's use a new line character here. Now it should work fine. Let's compile this first, and then we will run this. Okay, no problem. Why it's showing enter your response? Okay, we have run .arr. Okay, no problem. uh, nice. It has, I think it has taken the previous responses, no problem. So we will run now fib. Okay, so 0 1 1 2 3 5 8 13 21 34. So I guess you are capable of doing code tantra all by yourself. Nah, pretty boring. I'm not into data structures na, that is why. It's simple yaar, बहुत simple है. I'm just building a base so that I can quickly shift to Cypher. Let me show you something. I have to switch off my screen, I guess. Let me show you one thing, that what I will be beginning next. It's a pretty uh, it's not basic, it's above pro thing, not intermediate, not professional. It's above cybersecurity. It's the backbone of cybersecurity, that is cryptography. uh, Let me just transfer the file once. Send file. I think it is hacking the art of exploitation. Yes, it is. Done. I think my screen is not visible still. I'll be showing the screen in quite a few minutes. Open. I think my screen is visible now. Since someone should not think that we are doing very basic, so I should show you one thing. See this. I think it's a bin sh file overlooking the obvious. Where are the C programs? Was this the right OSI model? I think they have created a server. Okay. Okay. So why I am insisting you to learn arrays? So you can see they are constructing a constructing a buffer server, and in that I guess unsigned char byte. Okay. I think they are blocking particular kind of, so best way to show how these functions are used in, by example, the following server code listen to TCP connection. Okay, so they are restricting some port numbers in a server connection, so that is how they have written a program. So let's just start from the beginning. stdio, standard library string, syssocket, okay, netnet, arp, inet, okay, hacking.h. So I guess they have created a custom header file for hacking.h. So they have defined the port 7890. They have created another function inside this, and this is on listening this on new sock fd. We will be defining this new sock fd, I guess. uh, So PF, INET, and SOC stream, these are the particular kind of port numbers that it is kind of accessing, and we have defined buffer to 1024 that it is the data size and packets that we want to receive through this particular port 7890. I have given you a hint what we will be doing in future. Why C is necessary. I think they have also they are doing with RECV, okay, web client examples. We have, I think they are also dealing with SH files. Yes, they are. No, this is a not SH file. Starting nmap. Okay, for starting nmap, they have also created some kind of files. And this is a hexadecimal. Yes, hexadecimal value because it is starting with X. Okay, so they are writing a web exploit, I guess. Is it some kind of port binding? Yes, port binding shellcode. So when exploiting a remote program, spawning a shell locally is pointless. Port binding shellcode listens for TCP connection on a certain port and server up. Okay, same thing that I am telling. I think it is binding a port to search. So if you want to access port number 92, I am binding that port and redirecting you to the another port. So this another port can consist of a malware or something that you can accidentally download. This is garbage file, I guess. Okay. I think I have given you some kind of hint what we are doing in the future. So they have done a comparison between assembly versus C. So assembly is much capable of exploiting the system much good, I guess. They are using a to trace text editor to see the assembly code. Nice. Is this book on cryptography? No, this book is hacking the art of exploitation. It is not something related. I think I have copied the wrong book. It is not that book that I am telling, but I have given you a sense what we are planning to do. It will be covered after a long time, I think, around 8 to 9 months, because it is much more advanced. You don't know what is server buffer overflows, and you should be familiar with bash and programming. You should be good in at intermediate level. You should be good in assembly and C programming, because we are making exploits in order to destroy a particular system. Networking, okay. Asyn, okay. Asyn is also covered, I guess. Networking, okay. Syn flooding is also there. Denial of services, ping of death, teardrop, ping flooding, amplification attacks, okay. DDoS flooding, then TCP IP hijacking. That is I think port binding is there only. Yes, port binding, uh, that we are restricting a particular port and accessing another, and redirecting the user to go another port. So RST hijacking, fin xmas null scans, okay. Spoofing decoys. Then we are working with assembly instructions using stack. I think you have heard about stack and the data structures. So for building the foundation, I think we have countermeasures. Cryptography we have also. Okay, so we have RS encryption, Peter Shor's quantum factoring. We are working with quantum computing also, quantum key distributions, computational security. It's a much advanced topic. So offline brute force attack. So it is nothing but you are just copying the full server in your system and trying offline. Nice t-shirt, I would say. Jaguar. Thank you. So a lot. You should not directly jump to this because it's uh, very advanced. So we will be moving to our basics. That is arrays. Pretty basic. So we have done with Fibonacci. Now it's not that much. Okay, so using an array to generate a prime numbers. Now it's time to return to the prime numbers program that you developed in chapter 6. making decisions, and see how the use of an array can help you develop a more efficient program. So in program 6.10a, the criteria what that you used for determining if a number was prime was divided the prime candidate by all successive integers from 2. Okay, so you are just running a loop from 1 to 100, I guess, and you are just dividing everything by 2 and just checking if the number is divisible by itself and 2 or not in order to get the prime numbers. So let's just directly move to program. Okay, so I think they are using bool concept here. They are using bool concept here, so that is why they are uh, importing one more library or using a one more header file, that is standard bool.h. Okay, so for that let me do ls. We have prime, something kind of prime or something, no. So let's just create a program, micro prime dot c. So we are using two files, modified. Okay, so copy till here, copy paste clipboard. Now what we will be doing, so since we have seen that for loop running we want to use I, you can use any variable here. And for checking prime number p, we want to define array, so using p, not p specifically, we are using pr. And let's go it till 50. And we need another, no, we don't need another variable, but we need to use something for I is used for running the loop, but we need something for running the index of prime. Brute force to array is a quite long loop. Downfall, you can say downfall. But in order to learn that things that I have shown you there, uh, this the goal of this book is to share the art of hacking with everyone. Understanding hacking technique is often difficult. Okay, so in order to learn these advanced concepts, you should have you should be getting familiar with each and everything from basics. So we need something to index prime numbers, so we'll be using pr. Nice. Yeah, program. We will be using pri, pri for indexing, and we will be, since we will be starting from 2 because prime numbers, first prime number is 2, we will be initiating with 2. And just, okay, I think I have done one mistake. We will be using comma here, not semicolon. uh, Similarly with the Fibonacci thing, we will be declaring the array, since we are storing these prime numbers in an array. So like Fibonacci, we have defined the 0th element and the first element. We will be doing the same thing here. So pr 0, so first prime number is 2 and second prime number is 3, I guess. So 1 2 2 3 5. Okay, second is 3. And let's just do one thing. They are using bool also, they are doing it with bool. So what we will doing, bool, and we will be defining a parameter that is prime. We are checking that if it is prime or not, the condition of true false. Now we are running a loop for, because the next number will be the prime number, next prime number will be 5, so we are just running it with 5. P is equals to 5. And here we are using p, we will be using I in order to access the, in order to check the particular element. So for prime number, for specifying the prime number in loop, we will be using p, but in order to check, we will be using I for dividing each and everything. So we are inside a loop, we will be doing nested for loop. So we'll be going till 50. So since the size is 50, we'll be going to 50. So 50 is not a prime number, so it will not be included here. So we can use smaller than is equals to, and we will be iterating the value again and again. And we should not be iterating it with 1 because 5 plus 1 is 6, and we should be iterating it with, because we are checking or dividing by 2, so iterating each value by 2 here and just starting the loop. So we are entered in a loop, and now we want to check if the number is prime or not, and we are iterating it with 2. So let's do one thing. Since even numbers are all after 2, all the even numbers are not prime, so we are shifting directly to our concern to the odd number. So after 5 it will be 7. 7 is also a prime number. After 7 it will be 9. 9 is not a prime number, so we should not do p plus plus in order to make the program efficient. So we'll be checking that is the number prime or not. Is prime is equals to true, and now we will be running on again a loop in order to check, in order to divide everything by 2. So we will be starting with 1, and now since now what we need to do, we were checking two conditions here, that we want to divide it by 2 and we also want to check if the number is prime or not, and we want to print it at all at once. So what we can do, we can not directly specify the element number, and we need to check two conditions simultaneously, and both the conditions should be true. So firstly, we can use logical, or no, we in order to check the both the condition are true or not, we will be using logical and here. And now we will be doing divide p, because we are accessing the prime numbers and we are checking it with each and every number that is present in the loop. So prime, or p, I have represented with pr, I guess, pr, and bracket with I. Now what we will be need to check if the number is greater or not. Okay, so greater than is equals to, it will work or not. Greater than is equals to pri, I or I plus 1. It will be I, because we are iterating the value later by I plus plus. So okay, one problem. So this loop is just starting the number, or starting the array from 2 3 5 7 on, and this loop is run in order to check the divisibility by 2. So now we are checking if p percent, because we want the remainder p percent, and we are checking with the prime, the array pr, and I is equals to 0. So print is prime is false. So since we have used a bool concept, we can use this is, so like, let me just do one thing, start this with the loop, and it is, since the if condition is running in the loop, if prime is false. Okay, false. Firstly, we have set this is prime to true. Now we are checking. In order to check, we need to specify. So is prime is false, else is prime. Okay, so else, so the program know that if it's either false or true. So in the first condition we have specified it is false. So now what we need to do, we need to print the program, or print the numbers. So in order to do that, we will be again using, so in first case that we have seen, we have specified that is prime is true here, but as we have divided it with each and every number present in the array and check it with 0, we have specified that is prime is false. But in the case if is prime is true, what will happen? It should print. No. So if is prime is equals to 0, no, is equals to true, in order to check. So we are printing now, or just incrementing the value. Again, we are, is this inside the for loop? They have not specified. So we can now start here. We need to terminate it with another bracket. Where's the program? Communication between the modules. I think I have come far. So now what we will be doing, we'll be storing the each and every index in the variable. So let's do pr and prime index. For prime index we have used pri, capital I. We are specifying it with p, terminating, then again we'll be doing pr because we are increasing the index of each and every prime number in the array. Now it is done. We will be printing the values if is completed. So for nice. So for I is equals to 0, uh, we will be going till the prime index because we don't know how much number are present from 5 from 2 to 50, how much prime numbers are present here. So we'll be going till the prime index pr capital I, and what we will be specifying, we'll be iterating the loop by plus plus, and we do one thing, we will be printing printf. Since it is integer, we'll be using format specifier as this, and the name of the array, that is pri. And now we are just terminating it with semicolon. Let's because we need a new line character, let's do one thing, printf, print a new line character here. It should work now. For if क्या colon नहीं आता, I think it should be working now. Control SQ. There might be some errors. So GCC prime, and we will be writing the output to prime. Okay, so false, the spelling of false. Okay, basic errors we have encountered. Not that much. What happened? False. And we have not terminated this control SQ. Let's see the output. Okay. Uh, okay, compiled prime 4194304. What is this? Hmm. The output should be like this. We are getting like this. Let's just compare the program, what mistakes we have done or what. Okay, int they have used pi, we have used pr, and for indexing we are used pri. They have also initiated the value, we have also initiated the value. Starting the loop with +2, again starting the loop with +2, checking is prime is true or not. Okay, I is 0 again is prime, and p divided by primes, that is p index number I should be greater than is equals to pri, and again iterating the value. We are checking if p divided by all the indexes number is equals to 0, so is prime will be set as false. So if it is not set as false, if is prime is true, so pr primes same. Okay, prime index, that is pri, which is set to 2 first, should be equal to p variable this, and we are iterating again, close the bracket. What mistake we have done here? Okay, I think it's not running in a single loop because we are using loop inside loop. So here it is beginning is prime true. I guess I got the problem. Since it is a recursive for loop and it should be nested for loop, so it should come under this condition. So now it's beginning. This is the closing bracket of if, I guess. Then print is outside and not need to set the system state to 0. Let's try to save this control SQ. I think the problem is with the loop. uh prime, it's now returning 16. Nice. Micro prime dot c, where we have done the mistake. I think we have created one more program for the checking of this. I think this is for loop, cat for loop 2.c, end void give any number, num triangular number. No, this was not, because it should be in the decision making, I guess. Nested for while switch, bool, decision. Okay, decision dot c, I guess it is decision dot c, cat decision dot c. uh Enter number. No, it's not the one. It's not for loop. Is it condition dot c? Enter a value. No. For loop, fp is the first program. GCD grades nested, I think it is nested. Prime is just created. I have just created the prime. It's not arithmetic. Let's do one thing. Let's go to decision making once, making decisions, and see the prime number here. Even odd, calculating the average, making decisions. Okay, so prime numbers, I guess here it is. Leap year, nested if, else if. Where's the program of prime numbers? Is it inside nested for? I guess this is the one. Nah, this is not the one. This is not the one. I should be documenting the code, I guess. Operator, if else. Single character encoding, implementing sign function, else if. Where is the program of prime number? Is it in for loop? Break statement. Implementing revise to reverse the digit. Do uh, using while program to introduce the while statement. Not this. Using nested for loops. I think if they have bool, is it inside? Sorry for taking that much time, but I want to see what was the initial program. Generated number triangular. In which stream we have done the prime numbers? Because we have used for and if both. So it's not in for, not in if. Where is it? For number, right? Introducing the file statement, init expression, reverse. I think it was in decision making. Program to calculate absolute value, average, if else, number is even or odd. Program, okay, revised program. year is leap year or not. Oh, where is it? Okay, evaluating simple expressions. Okay, where is the program? I lost the program here. It's not even here. Add earth bool. I think it is bool.c. Cat uh, bool.c. Okay, so this was the program, I guess. So now we can compare both. We are using array in this, but in this case, I think I have got the error. I think I've got the error now. Minimum value, maximum value. Okay, top-down programming. We are much far. Arrays itself a big chapter. Mm, okay, we are in functions. Nice. We have done initializing array. Where is the program here? Number to convert. Introducing character arrays, initializing array. Okay, so this was the program. Our program is both programs are much similar. The only difference is the naming the variables. And let's see what happened here. So we have taken P and D. We are running the loop from 2 to 50 and we are checking is prime is true. And we are again running the loop for D is equals to 2 and D should be less than P for this loop. And we are if P percent D is equals to 0 is prime is false. So if is prime is not equals to false or it is true, so printf P. Okay. So it will be printing the loop here. And similarly, we are doing here, we are running the loop till 50. We are running the loop. Okay. So there's a little bit change because we want to implement array. So we need to initialize some values before. And is prime is true. Is prime is set to 2 here also. Okay, D is equals to 2. Again, it's starting from 1 because indexing is 1. Should be greater than 0. P by PR1. It should be PRI, I guess. I got the problem now. Now it should work. Control SQ. It should be running now. 0. Nice. Uh, let's check the structure of the program once. Mm, let me do one thing. So, new tab, micro prime 2.c. Let's just copy paste this program in order to check if it is right or wrong, because we have also followed the similar approach. uh, gcc gcc prime 2.c, writing the output to prime 2, hit enter. Okay, so this expected before this token. What specific error I have done here? Okay, where is the bracket? Where is the condition यार, ये क्या था? So is prime 2, why this is here? Okay, is prime. It should be working now. Control S, Control Q. Okay, let's try to run this prime too. Okay, it's working fine. So we need to see what error we have made here. So they have initialized P for the prime numbers, checking the prime numbers. P till P is equals to P plus 2. Initialized with 3. Prime index is set to 2. Okay, bool is prime, bool is prime. Uh, what's because here we have used like this. Okay. PR2, okay, is prime is true. They have initialized the loop here. Again, the loop is running. Prime is this PRI set to P plus plus PRI. Why is the error coming then? Because we have used I plus plus. Is this the error? Because they are using pre-increment, we are using post-increment. Is that making any difference? It can make difference because they are just firstly incrementing, then assigning the value. We are first assigning the value, then incrementing. Let's just try to run this. GCC prime again 0, so it should be not making any difference. It's true. Not getting the exact error that I have made here. Just change the variable, everything is all right, I guess. So this program is running and this is not. What's the difference in both? PRI prime 0, much detailed program, 2 3 4 loop 5. I think I have. Let's just, I should, I think it should not make any difference, but we are running it till 50. It should not make any difference, but I will be, hello BS Sastvik. Hi Satvik. In this program we have initialized header file std bool here also. There's just a change of variables, but 2 3 loop is working fine. P is equals to P plus 2. Is prime is equals to 2. Is prime is equals to 2. Initialized a for loop here, satisfying both the conditions. PRI. Okay, plus plus I is false. Prime is equals to false. Okay, so if is prime is equals to 2, so I think I have got the error because this if is prime is also inside the loop. In my case, it's not. Okay, it is inside the loop. Still it is giving error. It's not giving error, but it's not running the way we want it to run. Plus plus I. Return 0. Let's try to add return 0 also, although it will not make any sense. It's again returning 0. Let's just try to understand the program. I hope we can find the mistake in my case because it's exactly the same, but there's just a difference between the variables that I have used. Uh, so p divide primes I greater than is equals to primes I. Okay, p divide primes I. Okay, no problem. So much similar to this case, like uh, we are checking it like this: if it is divided by p or not. P divided by d is equals to 0. So much similar to this case. So in this we are checking the division with 2, but I guess in this we are checking the divisibility with each and every number. So as a further optimization of the prime number generated can be easily readily demonstrated that any non-prime integer n must have as of its factor as an integer that is less than or equal to the square root of n. This means that it is only necessary to determine if the given integer is prime by testing it even divisibility against all prime factors up to square root of the integer. Okay, version 2. It's version 2. We are on version 1. Where is the version 1? Okay, version 1 was covered in the previous class. Okay. So let me just open the program here. So this was the program. So is used to intermost for loop as a test to ensure the value of p does not exceed the square root of prime psi. Square root of prime psi. Okay, so this test comes directly from the discussion in the previous paragraph. You might want to think about the math a bit. So program 7.4 storing starts by storing 2 and 3. Okay, as the first two prints in the array primes. Okay, so this array has been defined to contain 50 elements. 50. Is there any chat? Okay, so the variable prime index initialized set to 2, which is the next free slot in the prime array. A for loop is set up to run through the odd integers from 5 to 50. Okay, after the boolean variable is prime is set to the true, another for loop is entered. Okay, so boolean variable that is prime is set to true. In my case, is prime, the spelling of his prime is all right. So the boolean variable is prime is set to true, another for loop is entered. Okay, the loop successfully divides the value of p by all of the previously generated prime numbers that are stored in the array primes. So the index prime 0, which is 2, this is true because our program does not even consider even numbers as possible primes. So inside a loop, a test is made to see if the value of p is evenly divisible by prime psi. Okay, if it is, then is prime is set to false. Okay, so they are checking the divisibility by each and every element in primes I array. Okay, so the 4, I think they have, yes, they have covered that also. So the 4 continues execution as long as the value of his prime is true. Okay, so and the value of prime psi does not exceed the square root of p. Okay, p divided by prime psi greater than, okay, square root of p. Okay, if you try to solve this, what you will get, because since it is p divided by pi and greater than is equals to pi, like this. So if you just go there and you are checking that it should not be greater than the value of I, it should not be greater than p, like this, or pi square, because it goes here and multiplication it got squared. So if you solve it a little bit, you will get this square root like this. Okay, so if this and this, okay, plus plus I, if p is divisible by prime psi, all the numbers present in this array is equals to 0. So if you get the remainder 0, so it will be evenly divisible and is prime is set to false. If is prime is true, if it is true, because if the numbers are the doesn't leave the remainder as 0, so prime's prime index is equals to p. So plus plus prime index, it is increasing the value of the index in the present in the prime. So after executing the for loop, a test is prime flag determines. Okay, I think we have this true because our program does not even consider even number as possible primes inside the, okay, it is then is prime set to false. Okay, so the for loop continues execution so long for as the value of its prime is true. If is my webcam working? Yes. So after all values of p have been tried, the program displays each prime number that has been stored inside the prime arrays. So it is storing the all the numbers that are tested in this prime array. We have specified like this, and just increasing the index so that it is changing the index every time and storing a new value after checking this. So after all the values of p have been tried, the program display each prime number that has been stored inside the prime arrays. The value of the index variable I varies from 0 through prime index. The number of arrays like 50. So minus 1 because the prime index was always set pointing to the next free slot in the prime array. Okay, pretty good program, but why my program was not working, I still didn't get to know that, because it's absolutely same, no difference. The difference is just the naming of the variables. Still not able to find why it is wrong. Pri is our prime index here, which is set to 2. Increasing the Pri, still not able to get why my program is not working, but because it's the same program, we have used the same concept, we have just changed the name, I should say change the name of the variables. Stream is, I think we will be only covering arrays today again. So initializing array, just as you can assign initial values to variable, let me just do one thing. Bookmarks, add bookmark. Okay, page 106 is added to bookmark. I will see it because why my program, I will be covering that in the next stream, why this not work, because we need to know what mistakes we have made in order to learn. So initializing array, so just as you can assign initial value to variable when they are declared, so can you assign initial value to the elements of an array? This is done by simply listening the initial value of the array starting from the first element. Values in the list are separated by commas. Okay, pretty good. Okay, so you can pass a list inside a curly braces. So set the value of integer 0 to 0, integer 1 to 1, 2 to 2, 3 to 3, 4 to 4, 5, and so on. Okay, so array of characters are initialized in a similar manner. Thus, the statement character letter is 5, A, B, C, D, E. So defines the character array letters and initialize the 5 element to the character A, B, C, D, E respectively. So 0, 1, 2, 3, 4. So it is not necessary to completely initialize an entire array if a few initial values are specified. So only an equal number of elements are initialized. The remaining value in the arrays are set to 0. So the declaration like this, if you are taking float values, so it will be only assigning the value, take only 3 values and sets the remaining 497 values to 0. So it will take 0, 1, 2, the index 0, 1, 2, and all the values will be set to 0. So by enclosing an element number in a pair of brackets, specify array number, array element can be initialized in any order. For example, this. So is this a position or index? Pair of brackets specify array elements can be initialized in any order. For example, like this. So float number they have used. 2. So I think it, okay, so it is the index number. So we can just in the curly braces mention the index number and we can specify the values. So for that we have, let me just do one thing. Let's just close this and open a new instance. Let's move to our parent directory, desktop work, C, ls. Okay. So, hmm, we have seen, I think I have created a program, arr.c, cat arr.c. Okay, so we have initialized like this. So you can just do one thing. You can just use vi or v10, v11, and you can just initialize the number that you want to, the index number you want to access, and you can store the value like mentioning the index number like this. Okay. So initializing the sample data array to the same values as shown in the previous value. So and the statement index is equals to 1 2 3 3. So okay, so if you specify a variable outside the array, you can use that inside a variable inside an array. So for that, at index number 9, you want a value that is x plus 1, like 1 2 3 3 plus 1, like 1 2 3 4. So you can specify like this. So define a 10 element array and initialize the last element to the value x plus 1, or 2 1 2 3 4, and the first three elements to 1 2 3 respectively. Okay, so 0 is set to 1, 1 is set to 2 is, so if we talk about position, it is the first position, 0th index. So the first position, it is 1. Let's take a quick water break. I hope I am audible now. Let's start again. I am audible. Am I audible? Let's just see. Yes, it's working fine now. So we are at Let me just do one thing, because I have not updated the system today. Sudo apt install. Okay, I think I have messed up. Let's just update our system for a bit. Let the system get updated a little bit. I think we can resume. It should be. Let me launch a new instance and begin with our programming. CD work, C tab extra. Okay, so we are at initializing the arrays. Illustrate two types of array initialization techniques. Unfortunately, C does not provide any shortcut mechanism for initializing array element. That is, there is no way to specify a repeat count. So if it were desired to initially set all 500 values of sample data to 1, all 500 would have to be explicitly spelled out. In such a case, it is better to initialize the array inside the program using appropriate for loop. Okay, I think they have stored the value with squares. Yes, I multiply I. Okay, so they have initialized fewer values till 16, and they have run from 5 to 10, and for the remaining values they have used I multiply I squaring. For printing, for why for loop is used with arrays, either to print or to store anything inside the array. Uh, you should be matlab, for doing everything in array, like altering the elements, accessing any element, printing, changing, altering, deleting everything you have to do it with the for loop. You have to initialize a for loop first, then you can do. So first for loop is run in order to specify value, like for squaring the values. The second for loop is run in order to uh, print the values. Pretty basic. In the declaration of array values, the first five elements of the array are initialized to the square of their element number. For example, element number 3 is set to equal 3 square, element number 3. So 0, 1, 2, 3. Okay. So 0 square of 0 is set to 0. Okay. So 1 is 1, 2 is 4, 3 is 3. Okay. Pretty good. So this loop set each of the element 5 through 9 to the square of its element. So it is going till 9 because only the size of 10 elements are defined. So 0 to 9. So the second for loop simply runs through all the 10 elements to display. I have already told. So character arrays. How much it's left in this? I think arrays will be covered. Although I have planned to cover arrays, functions, and structures, but only arrays will be covered, I guess. arrays, and we have, okay, much programs, const qualifier, multidimensional array. I think we will be more working with matrices. Okay, I think it's, we can do functions, a little bit part of functions. So what we can do, we can cover arrays today, a small portion of functions, or half of the chapter of functions, then half functions plus structure tomorrow. We can do it like that. So character arrays. So the purpose of program 7.6 to simply illustrate how a character array can be used. However, one point is worthy of discussion. Can you spot it? Let's try to spot it. Character word HELLO. Okay. I for I is equals to 0. Hmm. Is there something? Okay, so we have seen one thing that we have not mentioned. What we can say, size. We have not mentioned the size this time. The most notable point in the preceding program is the declaration of the character array word. Okay, there's no mention of the number of elements. Yes, I got the point, I guess, because the number of elements that we are accessing in array is not mentioned. The C language allows you to define an array without specifying the number of elements. If this is done, the size of array is determined automatically based on the number of initialization. Because program 7.6 has 6 initial values listed for array word, the C language implicitly dimensions the array to 6 elements. Okay, so we have not mentioned the number of elements that we will be using, but we have directly mentioned the elements that we are using. So C programming automatically get that we are working with 6 elements. Pretty good. So but the restriction with that is we cannot add or access any more elements, or do more stuff with arrays. So please wait for 1 minute. Sorry for the disturbance. I hope I'm audible now. So pretty basic program. We have seen that we don't need to specify the number of elements. We can just directly write the elements that we want to use, but the restriction is with that is we cannot do more things in the program out of the specified elements we have mentioned in the program. So for a character we have used %c, already known in the format specifier. So this approach works fine so long as you initialize every element in the array at the point that is defined. If this is not the case, you must explicitly dimension the array. I have already told you that. In the case of using index number in the initializing list, as in this float sample data, the largest index number specified sets the size of array. In this case, the sample data is set to contain 100 elements based on the largest index value of 99 that is specified. Blur. क्यों हो रहा है? Okay. So where were we? Base conversion. So we will be doing base conversion now. We are already known the decimal, hexadecimal, and octal. So let's just move. So next program further illustrate the use of the integers and character array. So the task is to develop a program that converts a positive integer from its base 10 representation into its equivalent representation in another base up to base 16. Okay. So converting an integer from base 10 to base 2 The first step in developing such a program is to devise an algorithm to convert a number from base 10 to another base. So an algorithm to generate the digit of a converted number can be informally started as follows. A digit of the converted number is obtained by taking the modulo of the number by the base. So, okay, 0. A digit of the converted number, okay, so the number is then divided by the base with any fractional remainder discarded. Okay, so if it is divided by 2, like in the case of 5, if it is divided by 2, the fractional part of 0.5 will be discarded. And in this case, when 1 by 2 is done, so 0.5 will be written as 0. 0.5 will be discarded. Why the camera angle is changed? Is the camera angle changed? I don't know. I don't remember if the camera angle is changed or not. Was it like this? Was it like this? It doesn't matter यार, camera angle क्या matter करता है? Is it okay now? I think it's not the camera angle, it's the light. Yeah, okay. I think I don't remember specifically what's the camera angle. It doesn't matter. Okay. So the outline procedure generates the digit of the converted number starting from the rightmost digit. See how this works. नहीं यार, वैसे ही notice का. Okay, no problem. So the outline procedure generates the digit of the converted number starting from the rightmost digit. So how this works is the following example. Suppose you want to convert 10 into the base 2. So show the steps that would be follow to arrive the result. So the result of converting 10 to the base 2 is therefore seen to be 1010, reading the digits of the number modulo 2, okay, column from the bottom of the top, so 1010. Okay, so they are doing prime factorization. Let me just show you what they are doing. They are doing nothing but prime factorization, divide by 2 every time, so 2 into 5, remainder 0, so 2, 2, remainder 1, again 2, 1, remainder 0. So it will be read like this, 1010. So the 10 in the what base we are converting. So 10 is in the base of 10. But when we want to convert to base 2 or the binary notation, we will be doing 1010. So simply like this. Let's take another example. Like if we have number 25 and we want to convert it, we will divide by 2, 12, it will be leaving remainder of 1, so then 2, 6, leaving remainder 0, I guess, 2, 12, 24, 1, 2, 6, 0, 2, 3, 6, it will be 0 again, send 2, 2 ones are 2, 3 is 6, 2, 12, 2 ones are 2, remainder 1, 0, 0, so it will be like 0, 1, 0, 0, 1, 2, 1, 3. No, it will be not like that. So we got 1 now, so it will be like 1 0 1 double 0 1. So this is how base 10 to base 2 conversion happens in mathematics. So now they are making program to do this. You should not be focusing on the terms more daily or something, until unless you want to do mathematics. But to write a program that performs the preceding conversion process, you must take a couple of things into account. So first, the fact that the algorithm generates the digit of the converted number into reverse order. Okay, so we want to store it in an array, because when we read the output, we will be not reading like this. Instead, we will be reading like this. So we will be storing that like this, and we will be reversing the array. Okay. So you certainly can't expect the user to read the result from right to left. Right to left. Okay. Or from bottom of the page to upward. Okay. So we are reading the output from bottom of the page to upward, but we want to reverse so that user get it easily. So rather than simply displaying each digit as it generated, you can have the program store each digit inside an array. So then what you have finished starting converting the number, you can display the contents of the array in the correct order. Second, you must realize that you specified for the program to handle the conversion of numbers into base up to 16. So this means that any digit of the converted number that are between 10 and 15 must be displaying using corresponding letter A through F. We have already discussed that. Wait for 1 minute. I think, uh, is it working or not? My webcam is not working. It's not charged. Please wait a second. Yes, it's not working, I guess. No problem. We should be continuing without the webcam. I'm audible or not? Uh, I should be audible. Okay, let's begin without the webcam. I think there's a power cut and the light is not from past 4 hours and without the supply of electricity. Power manager battery is discharging. Okay, so let's just continue the stream and we will be seeing that how much our laptop can run on its own without power. So, on which triggers? Okay, so this was the updation, I guess. Hmm. So I've already told that in the hexadecimal thing from 10 to 15 you cannot just directly mention the number, you have to go from letter A to F corresponding. So in the in the program 7.7, to see how these two issues are handled, this program also introduced the type of qualifier const, okay, which is used for the variables which whose value does not change in the program. Mm, okay, so this concept is also new to me, const. I think I use const in JavaScript or something. So this program also introducing the type qualifier. So const is known as type qualifier, which is used for variables whose value does not change in a program. So the value of these will not be changed in a program. But okay, so they have mentioned the base digit 16 to 0 to F like this. So let's just see how the program is working. So they have taken the converted, what they are doing exactly. Program to convert a positive integer to another base, but which base? Okay, so they are mentioning the base in which you want to convert. Okay, so 10 in the base 2, they are doing like this in the base 16. So they are converting the base 10 either to base 2 or either to base 16. So I think they will be using case. No, they are not using case, but while okay, let's just see how I cannot directly interpret what the program is doing. Firstly, this is already known to you, but we can use const for those variable whose value does not change in the program. So we are specifying the base digit 16 for the base digit 16. We are defining characters from 0 to 16, but after 10 it will be shifted to A to F, like it's 10 is A, 11 is B, then 12c, and so on. So we have taken int because we are converting positive integers, so converted number, and we are taking long int number to convert. Okay, int next digit. Okay, base index 0. Okay, so get the number and add the base, okay. So printf number to be converted, we are taking the input and storing to number to convert. We are using long int. Okay, long values for the long values. Okay, so now we are asking which base we have stored in the base. Okay, and convert to the indicated base. So converted number index, let's specify it with I is equals to 0, and is equals to number to convert. We will be dividing because we are using prime factorization method, I have already told you. So we are just dividing the number. So we'll be dividing the number by the base. So for example, if we are converting a 10 base number to 2, then we will be dividing the number to convert like 10 to 2. Okay, and what we are doing, we are storing the values of the remainder, that is like we are storing these value inside this, and we are just increasing the index one by one, and the number to be converted is to number to convert by base like 10 by 2. So we are also storing this value, so in order to do the prime factorization of this value. Okay, pretty good. So firstly we are doing this, and then we are specifying the conversion, like you have to stop when the number is changed to 0, like we have stopped here. So we will be doing this like one more time. So 2 0 the 0, and we will be reminding that remainder live to 1 like this. And if the final number is 0 here, because as you know that 2 ones are 2 and the final number, the remainder which is left is 0. So when we move upward and get 0, so we'll be stopping our condition here. So this is done in order to stop this do. Okay, so why we have used do not for, because we don't have any particular condition to stop, but we need to do it one time before the condition is applied. So for the do loop, what it does the program, it performs the program once, and after that it checks the condition. So even if the condition is false, the program will be executed once. And same happens here. Firstly we have specified what we need to do, and here we have uh, taken the remainders and store it in converted number index, store the all the elements of the array in this converted number. Then we have told that if the number is 0, then stop the loop or break the loop of 2. So display the result in reverse order. Now we want to reverse it. So what we will be doing, printf converted number is equals to what? So now we are decrementing the index. So we'll be decrementing the index from, we don't know how much the index, what's the value of index. So we'll be directly using the decrementation, like minus minus I, that is post decrementation, and we will be going till the index 0. So if we have let me just erase this. So if we have used the example of 10 here, and 2 5s are 10, leaving remainder 0, 2 2s are 4, leaving remainder 1, 2 1s are 2, leaving remainder 0, and this is how it is stored. So this will be stored like this here, 2 3. So firstly 0 will be stored, because the remainder will be stored, then 1 0 1, but we need to, and the index number is 0 1 2 3, but we need to print the values from the back side. We want to reverse this. So what we will be doing, we will be decrementing the index number till 0. Like first the index is set to 3 itself because it is plus plus index, so the index is incrementing again and again, so it will be set to it will be set to 3, and we are decrementing it. So 2 1, and it will be stopped at 0 when it is equals to or greater than 0. So the next digit, what we can say, the final output is stored in this. So next digit is stored in the converted number index and printf, we can just, they have used base digit. Base digit is okay, so we need to convert that in the hexadecimal thing. That is why we have used base digit, and the next digit is stored here. Okay, so in order to change the output like this 0 to f, they have done like this. Okay, so if it will be like octal, it will be working like from 0 to 9. If it is exceeding the value after 9, it will be treated as base digits, and base digits we have already used here. Like we have defined it for till 16. So if the value is incremented after 9, a b c d will be used, but in the case of octal it will not be it will not jump after 9. So this is how it done. Let's just try to run the program in our terminal. We'll be creating a, let's just try to do a small uh, convergence in this base2.c. Okay, so just copy this content here so that our time will be const base digit. Okay, now what we will doing, we'll be using int, and firstly we'll be using the converted number. So converted number can be specified as c converted number, convn, or we can use cn, yeah, converted number. And let's take a size till 64. Okay, let's take another, like we want to store the data in something, so long it, the number need to be converted. So this is the converted number, and we will take the number need to be converted, so number need to be converted ntc. Okay, so since it is not an array and it's a number, okay, so we'll be like doing like this. Converted number will be stored like this. Let's do like this, so it will be easily accessible. And we'll be taking few more numbers like int. So for reversing, we'll be taking next digit. Next d is good. And for accessing the elements, we will using I. For base, because we need to treat it, what's the base, so we'll be using base in order to get to know what number to be divided with number to be converted, n to c. So we have done with the variable declaration, and we will be doing now printf. Please wait for a minute if there are any chats or something. Today's less audience as compared to the previous streams, no problem. Now we'll be taking the input printf. So number to be converted, scanf. We will be since it is an integer, we'll be using, and since it is a long integer, long int, we have to use li, and we will be using and store it to n2c. And let's just terminate this, and now we'll be asking the base. Let's just take this from here. Okay, base, and we have also taken base here. Now we will be doing our things. So firstly we will be doing before specifying the condition, because we need to run at least once. So the converted number, or the convn, is equals to the, okay, so since it is an array, so we'll be specifying the index. So conv is 64 and the index is treated as I, so it will be treated as I. And it is like, does it even help? I always skip these practical parts and focus more on theories and learn with C++ directly. It's your choice. Totally your choice. C++ is useful, but it's not that much useful when we talk about exploitation. I think you are treating this channel as a coding or something, but I should tell you one thing. This is a channel related to cybersecurity. Uh, are you there in the stream? So I should be telling why I am doing that from basics. Want to know the answer? If you want to know the answer, you can just print yes. I can show you practically why I'm using C, specifically in cybersecurity, or we talk about in ethical hacking. So CONVI, and we need to see the number to be converted into C, and we will be just needing the remainder. So percent divided by the base that we have used, and now yes, you want to know the reason. Okay, let me show you the reason. So this is the reason. We will be next beginning with the art of exploitation. We will be doing memory exploitation, memory exploitation, and buffer overflow, and server formatting, and much exploitation. We will be moving to cryptography. So when you talk about cryptography and making exploitations, and if you are experienced a little bit, you know that all the operating systems are fundamentally based on C programming. So you can see this program. I think this is a exploit in the search, buffer search, and you can see this program. We are learning C from basics because we want to exploit the system. In order to exploit the system or test the system, so we need to create a script that is much similar to on which our operating system works. So like if we talk about Mac, Windows, Linux, all the operating system fundamentally based on C programming. That is why we are learning C from basics, so that we can make a exploit. We will be learning assembly too. I am not a developer or something. I am not a web developer or anything related to coding, but I am cybersecurity, and I just know basic programming languages, or all the older, we can say OG programming languages, C and assembly, that is used in the early times. I should not be explaining this because it's too upper level for you. You are not be familiar with the memory allocation part and something. If you talk about exploitation, okay. So I think you got the answer why we are moving that, going that much basics. So now we will be increasing the index, and I specified the index with I guess. Yes. So now what we will be doing, we will be taking the number to be converted into C. Okay, I understood. Thank you. So now we need the next number to be divided. So into C will be stored as into C divided by base, and okay. So now we will be writing a while condition. While condition is written outside the bracket now. Yes, it's written outside the bracket. So while the number is not equals to 0, so number to be converted is not equals to 0. And okay, working fine. So when we are using do loop with while, so after while we need to specify the semicolon in order to terminate, but when we are using while alone, you cannot use this because the terminating condition will be present here. Okay, pretty good. Now we want to print the result, or print the converted number, I guess. So converted number is equals to, now what we will be doing. So we are just accessing the numbers from the back, as I have mentioned here, that we will be going like this till 0. So we will be making a loop of decrementation, like for minus, we'll be initializing minus minus I, because we don't know what exactly the highest value of I. So we'll be going like this, and we will be going till 0, and again we want to decrement the value. Let's use a post decrement here, and since it is a for loop, we want to print the result, and we want to store it somewhere. And since it is converted and reversed, now we will be storing that in the next d, or next digit number. So like next digit is equals to CONVN, since it is an array, and it will be stored with index I. And now we want, if the number is base 16, so it will be allowed till 9, but Okay, let me do one thing. I think it will show error. Okay, I will be explaining. Okay, it's working fine. Okay, explaining it in a few minutes. I have already I have think I have explained all the things. That is why I'm writing the code now. I have explained this code that is written here, and I'm making a little bit changes here. I have explained it earlier. I will be explaining again. Don't worry. So now we have done this. If we want to access the base digit 16, so what we can do, since we want to print, nice. So printf, what format specifier they have used here? Percent %i or percent %c. Okay, so since these are the characters we have defined here, okay, so we will be using percent %c, not percent %i. But this is a number. We should be using percent %i, but as I have already told you, we have used const, and const is something like the variables whose value cannot be changed inside a program. They once they are fixed, they are fixed. In order to fix something, we should be using character, not the numbers. That is why they have, they are quoted. All right. Okay. So now since they are converted or treated as a character, we'll be using format specifier as percent %c, or since it is a character, not long character, we will be using percent %c, not lc. So now base d will be used. So have I defined base d? Yes, base digits, or you can say base d like this. So now we will be printing base d or using the variable base d with the index of next d, since the number is stored here. So terminating this, and the program is completed, I guess. For loop beginning, this happening, printf, although not needed, but let's end it with this, returning the system state to 0. Okay, I think the brackets are okay. Our do bracket, for loop bracket is working fine. Let's compile this. So gcc, what's the name of the program? Gcc base. Okay, writing the output to base conv, enter, lot errors. So scanf, invalid operand to binary. Okay, but we have specified now that li is here. Do they have used pointers in this? No, they haven't used pointers. Okay, let's ignore this. Plus plus I. Okay, n to c and to c divided by base. Is there something wrong with the? Okay, that is why it's throwing error, because and not used comma here. Okay, unexpected operation before this. Okay, print printf. Okay, printf, quite a few errors. Micro base sorts. See, when we first is this error inside this. Okay, second we have this showing error. Okay, like this. And third error we have, it's showing error inside this, but can they have decremented the value here also, but I don't think it is needed. We can do one thing, we can just leave it blank here, blank argument, it will work. Okay, printf, and terminating with semicolon, control s, done. Let's try to compile it. It's showing error again. Okay, unexpected expression before this. So it's post decrementation. What's the unexpected expression? It is post decrementing. We are post decrementing the value, minus minus index I minus minus. I use post decrementation na. Okay, we have to decrement it before doing something. Pre-decrement we have to do. So microbase so we'll be pre-decrementing the value, and we'll be specifying here also control sq. uh, Expected this before. Okay, so in for loop, I think for loop may we don't use semicolon. Why? It is telling me to use semicolon. Micro CUNV. So it's showing error inside this. But in for loop, we do not use semicolon. Uh, let's try to. It is showing error inside this. So here is the error. Right hand operand of a comma expression has no effect. Okay. Something wrong with the bracket, or if I just leave this blank and now try to control S, bindings, now it's working fine. Control SQ. Okay. I got the problem. For separating the arguments, we use semicolon. I have used comma. Nice. Controls. Escape. It should be working fine now. Okay, it's working fine. Base CONV. Number to be converted, let's use 10. What's the base? Let's use base 2. Segmentation fault. What's the test cases they have taken? 10 and 2. I think we need to specify index here also. Let's try to do it once. Uh, Here. I think it should not make any sense or something. Okay. Compile this, run this. Number to be converted is 10. Base is 2. Segmentation fault. Why segmentation fault happen? Copy selection. So segmentation fault occurs when a program attempts to access a memory location that is not allowed to access, or attempts to access a memory location in a way that is not allowed. Okay, it is trying to access a memory which is not allowed. But in the program, I guess, have we left the bracket blank? But you have specified that you have 64 converted number. So this is the converted number. Number to be converted is n to c. I think n to c we have not specified as array or something. N to c is not specified as array here also. Number to be converted. Okay, so n to c should not be, because it's a single number, it should not be as array, but a converted number will be array. Next digit will also be a single digit, not a, it's a single string, not comma separated values. The program is absolutely same. %c base t, next t, base digit is specified as this 16. So 0 1 2 3 4, like, I think the error is here. So this is 10, 11, 12, 13, 14, 15. So 16 values are there only. Okay. So plus plus index, everything is fine. So if there was a memory segmentation fault, it should be generating the error before the program is compiled. But let me try to run it once. I think I am out of space in my laptop. No, but it's taking hardly bytes. So number to be converted. Let's take another number. Let's take another number. They have taken 128362, 12828362. Base to be converted 16. Segmentation fault. But the program is absolutely fine. Let me do one thing. Instead of checking the program manually, we have understood what the program is. Let me just directly use this instead of this. There can be a possibility that I have done a mistake. So it is n to c base convert I index number to be converted percent base plus index number to be converted n to c base. It's pretty good. The program is working fine. Index is there, index is here. Have I used all the variables correctly? It's in the 27 line, then the 7th line. Okay. Let me do one thing. Let's try to use this program instead. This is a pretty basic thing and we should not be wasting our much time here. Although I will be, because one more error I have encountered in the array. Uh, we'll be seeing that tomorrow. I'll be debugging these programs offline, off stream. Let's try to run this now. Control SQ. If the problem is with the program itself. Base CONV. Number to be converted is 10. Base 2. Okay, converted number is equals to 1010. This program is working, but now my program is not working. Why? Why? We have done the same thing. Number to be converted, or it's a little bit elaborated, but I we have used here, I we have used here, base plus I here, next D, base D, next D, CUNVN. All the things are absolutely correct. What's the problem then? N to C percent base, N to C percent base, plus index, plus I. We have used N to C by base. All the things are working absolutely fine, but it's not running in my program. This program is running absolutely fine. I'll be finding the bug of stream. Return the system state to 0, system state to 0. All the things are correct. Why it is showing error then? Like, okay, let's just not waste time and move to const qualifier and read a little bit about this. So for the explanation of the code, so we have included the header file standard input output.h, then int main void. So in order to we know that C compiler has a restriction that it cannot directly define the hexadecimal values. So in the hexadecimal values, what we do that we cannot directly use 10, 11, 12, 11, 13, 14. So instead we have to use A for 10, 11 for B, 12C, 13D, 14E or 16F. So we have const. What it does, it defines the variable inside a program whose value will be same throughout the program, and it cannot be changed. So this is used at the last of the program. So the final result is stored here, and this is converted uh, like this. So if you are converting this string to base 16, so we have got the output something like 1, and f is 1 5, so it is 15 5 6 a, that is 1 0. So it cannot be differentiated. So for that it has taken f and a. So if we write 1 1 5, so you cannot differentiate it, either it's 11 or 1 1 5 different, or 1 15. So for that we have used f, because they have specified that this is f is alone, 15 is alone. So that is how it works. This is pretty basic. We are just accessing each and every remainder and try to store it in an array, and at last we are just running a reverse loops to reverse the array, because when we are just doing this prime factorization, we are getting the result like this, but we want to access like this, so we are just reversing the array. Const qualifier. The compiler allows you to associate the const qualifier with variables whose value will not be changed by the program. That is, you can tell the compiler that the specified variables have a constant value, or const is said as constant. So after initializing it or try to increment or decrement it, the compiler might issue an error message, although it is not required to do so. So one of the motivations for the const attribute in the language is that it allows the compiler to place your constant variable into read-only memory. Normally the instructions of your program are placed only into read-only memory. Okay. So in order to debug the error, or uh, solve the encountered error, like of this handling with the strings a b c d e f, so we have defined a const variable here, so that C program can know that they have used this, they have specified a variable here base digit 16, and this is how it should work. And C programming can store it in a read-only memory. So as an example of the constant attribute, the line const double pi. Okay, so since it is a float value of, it should be accurate. So for the accuracy we have used double instead of float, and we have defined that pi should be, this value should be treated as pi. So declares the const variable pi. This tells the compiler that this variable will not be modified by the program. If you subsequently wrote a line like this in your program, pi by 2, GCC compiler would give you a warning message similar to this, that warning assignment of read-only variable pi. Okay, so we can not just directly use read-only memory variable into our program, but we can use to just specify in order to change the printing format. So returning to program 7.7, the character array base digit is set to contain the 16 possible digits that will be displayed for the converted number. It is declared as a const array because its contents will not be changed after it is initialized. uh, my webcam is not working now, no problem. Let's uh, just end the stream because a small portion is left now. I think multi-dimensional array is left. Okay, not a big part. We'll be doing that soon. uh, where were we? Okay, so the array converted number is defined to contain a maximum of 64 digits, which holds the result of converting the largest possible long integer to the smallest possible. Okay, so if you use int, 32 digits are defined, 32 space memory can be allocated. But if you use long int, and if you want to convert a large chunk of number into a smaller one on a hexadecimal format or octet format or a base 2 format, you can use long int for 64 digits. So we have specified in the program 64 digits like this because it's a long int. So to contain the desired conversion base and index to into the converted number array are both defined to be type of int. Okay, after the user keys in the value of the number to be converted in the base, note that the scanf call it to read a long integer. Okay, ld or li, what. So let's just move to do loop, how it is working. So we have seen this also, but because it is extracting the remainder. So when the do loop is complete, the value of the variable index in the is the number or digit is the converted number, because the variable is increment one time too many inside the do loop. Its value is initially incremented by one in the for loop. Okay. So the purpose of this for loop is to display the converted number at the terminal. For loop. Okay. 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 No problem. So here we are performing the logic, we're extracting each and every number, and here we are what we are doing here, we are just using for loop in order to reverse the string that, or reverse the array that we got, or the remainders that we have stored, and reversing it and printing it. So for changing the printing format, we have used base digits. Okay. No. So this was a new program now. So in order to change or specify the program for base digit 16, so we have used this format, and we have stored into next digit. And when we are just writing the program or printing the values outside the terminal or in the terminal, so we are specifying that you have to use this format. Like, where's the format? Base digit, like instead of 10 you have to write a, like this. So for each digit from the converted number array, it is in turn assigned to the variable next digit. So each digit from this variable is assigned to this. And then what happened for the number 10 through 15 to be correctly displayed using the letter a through f, a lookup is then made inside the array base digit using the value of next digit as the index. So for the digits 0 to 9, the corresponding location in the array base digit contains nothing more than the character 0 to 9, which, as you recall, are distinct from the integer 0 to 9. Location 10 to 15. So if something happen like it's 16 or it's 13, so it will be going here, and it will be checking like what's the base digit 6 13. So 0 1 2 3 4 5 6 till 9, then 10 11 13. So it will be c will be extracted from here. So this is how it is working. We should not be going inside this preceding program with a build slope. No check was even made to ensure that value was between 2 and 16. Okay, one more problem that we have encountered in this program is that if some number is preceding above 16, what will happen? So if the user had entered 0 for the value of the base and the division inside the do loop, which would have been a division by 0, you should never allow this to happen. In addition, if the user had keyed in 1 as the value of the base, so the program would enter an infinite loop, because the value, it will be divided again and again. So you have to put some kind of restriction. So in chapter 8, working with functions, you rewrite this program, resolve these issues. Okay. So multi-dimensional array, the types of array that you have been exposed to do so far for all linear arrays, that is, they are all dealt with single dimension. The C language allow array of any dimension to be defined. Should we complete it tomorrow, multi-dimensional array? Because we have to have a dedicated time for that. Although I have decided that we will be covering the half chapter of functions, but we should not be going that much fast. Let's complete array. We will be finishing this soon. So till now we have seen single dimensional array. Now we will be seeing the multi-dimensional array. Or firstly, in this section you take a look at two-dimensional arrays. One of the most natural application for two-dimensional array arises in the case of a matrix. So in mathematics, you know what is matrix, so you will be easily understanding what is this. So consider a 4 multiply 5 matrix. So 4 multiply 5 is nothing but 4 rows and 5 columns. So rows is defined like horizontal and columns are vertical. So this is like R into C, or RC, you can say RC format. So in mathematics, it is quite common to refer to an element of a matrix by using of a double subscript. So if you call like you want to access this is M11, M12, 13, 14, 15, then 21, 22, 23, 24, 25, and similarly 31, 32, 32, 33, 34, 35, similarly. So if you want to access something, like if you want to access the element M23, so you will be going to, I have told you that it is a RC format. So 23 in RC format is second row third column. So second row third column, so this is the element that you want to access. So this is the way. So my notation M32 refers to the value 20. So M32, like 3, third is the row and 2 is the column. Like they in this they have uh, M45 refers to the element content. In C, you can use an analogous notation, which, when referring to, I think M32 here, like third row, second column. So this will be the 20. So this is a new example, T1 7.3, where in mathematics the notation Mij is used in C the equivalent notation M, like this double dimensional array. So two-dimensional array. So two square bracket will be used. So first will be used to specify the row, second will be used to specify the column in case of matrix, not every time, but in case of matrix. So remember, the first index number refers to the row number, whereas the second index number reference the column. So the statement sum m02 plus m24, like zeroth row, second column, like it's -3, and plus second row, fourth column, 14. So -3 plus 14, it will be evaluated as 11 to the variable. Okay, this is how it works. Let's just directly jump to the program. Okay, you can also, like, if you want to specify something, so two-dimensional array can be initialized in a manner analogous to their one-dimensional counterparts when listing elements for initializing the value are listed. Okay, so M45 is a way of writing, you can say, 4 rows 5 columns. So this is how you can enter. So starting the curly brackets braces and writing the first row, then comma, second row, third row. It's a way of writing or representing. Thus the preceding statement could also have been written as follow. Okay, so if you don't want to use double bracket, or you don't want to use the curly braces 2 times, you can write like this. It will automatically, as with one dimensional array, it is not required that the entire array will be initialized, a statement such as this, so it will automatically interpret it as this. uh, this statement will be automatically interpreted as this. So since in the one dimensional array you have seen that you can leave the values, so similarly in this, they have defined that there are 4 rows 5 columns, but in this case we have seen that they have taken only 4 rows, neglecting the they have taken 4 rows similarly to this, but the last 2 columns are neglected here. So only initializes the first 3 element. Okay, pretty good. You can do it like this also, like in the one dimensional array. So variable length arrays. So this section discusses a feature in the language that enables you to work with arrays in your program without having to give them a constant size. In the examples in this chapter, you have seen how the size of an array is declared to be a specific size. The C language allows you to declare array of variable size. So for example, program 7.3 calculates the first 15 numbers, but what if you want to calculate 100 or even 500 Fibonacci series? Or what if you want to have the user specify the number of Fibonacci series to generate? Okay. I think I got it. So you are asking, so how many Fibonacci numbers do you want between 1 to 75? So this time I am also asking the user how much number is needed, but still we need to specify some kind of range or something. So as of writing full support for every, we have seen Fibonacci, how it works. So, but we are doing that in a constrained. Uh, so till here, copy. So micro fib2.c, control V. So till here it's pretty much good. So now what we are using, we are specifying a condition that if num fib or fibs, it should be greater than 1. So the least value could be entered is 2, and we are using logical OR, and it should be also not, let's take till 50. So num, they have taken 75, let's take till 100. Num fibs, it should not exceed 100, so the last maximum value can be 99. So this is the condition they are using. So now using the same concept of Fibonacci, so let's just do one thing, copy this here. We are just telling the system that this program is not ending here, that is why we are returning the system state to 1. And what we are doing here, Okay, so unsigned long int Fibonacci. So it can be a since it can be a long number when we are just printing the Fibonacci series 200. I think my webcam should be working now. Let me just try to switch it once. It's working fine, I guess. Okay, so I think I'm visible now again, and where were we? We were writing a Fibonacci program. So if the number, okay, so bad number, sorry. I think I have specified something wrong. Okay, so if the condition is like that, if the number you have printed is smaller than 1, or if the number you have printed is exceeding the limit or exceeding the range, so it will be printed as bad number, sorry. If you are printing negative number, so Fibonacci series is not defined in negative, and it should not be exceed 100. So we are just constraining a program here. So what we will be doing, we are just doing there. So now we are defining some more, since when you are doing Fibonacci series, you have seen the numbers are quite adding again and again. So what we will be doing, we will be assigning int as long int plus unsigned. So the value should not be fixed here. Unsigned int, unsigned long int, long int. So now fib and num fib. So this is the index number, I can say. Num fibs is the index number. So this is the if condition. If it is like exceeding the range, or it's before the range, this will be printed. And if it's within the range, then this program will be executed. Now what we will be doing, we will be using the same concept. Let's do Fibonacci. As we have seen in the previous program of Fibonacci, we are just denoting the first index 0 with 0, 1 with 1, beginning the loop with 2 till num fibs plus I. Then we are just specifying that it will be the sum of the value of the first element should be the value of the element should be the sum of the previous two elements. So the value of I should be the sum of the previous value and the second previous value to it. So let's just copy this from here, and let's just copy till here, because I have to explain one more thing. Paste clipboard. Okay, so now we have seen how it is working. We have used for loop here. Okay, so what we are doing now, in order to print, we are again using for loop, but now we are just try to access each and every element. So we are beginning with 0 again, and we are going till the num fib, and we are just preceding the value. So we will be using increment operator I. And what we are doing now, see closely, printf, we are specifying the format specifier as, because it is long int, so ll, unsigned int for u, and we are just using like this. No need to write I. And we are specifying this Fibonacci now, Fibonacci, and specifying the index number I. Did I have taken I? Okay, we have taken. So I think the program is completed now. Printf. So starting here, so this bracket is also closed. It should work now. Control S, Control SQ. Let's try to compile this fib2.c output to fib2. Hit enter. Okay, lot errors, a lot errors. Let's just see. Parameter names without types in function declaration. Fibonacci long and Fibonacci number. Let me just quickly see what happens here. 14 15 square brackets, problem with the square brackets, again the problem with the square brackets. I think there is only one problem, that is the problem is the square brackets. Since arrays are represented, the index are represented in square brackets, that is why it is showing error. Now it should be working fine. Yes, so fib2, hit enter. How many numbers? So I think I have not, because we have specified a range 1 to 75, we have copied from here. Let me just quickly stop the execution, clear. I want to edit one thing, because now we are taking number from 1 to 100. We have changed the program a little bit. All that doesn't matter, it will not uh, change the way we are working. I think my webcam is gone again. No, it's working fine. So programming in C, and fib2 we have hit enter. How many numbers? Let's do 99. So the problem is that we are not able to differentiate. Can we do one thing? Pass a new line character here. Control SQ, compile, run. 99. Okay, now the numbers are present. Okay, so 0 1 2 3, we are familiar with till this, but it's like the addition of this. So 89 plus 144 is, let's just tick, because the addition of these numbers will be this. So it's like it's working like this. Okay, so let's try to do one thing. Let's go out of range 101. So bad number, sorry. Okay, it's working fine. Let's go to negative numbers. It's working fine. Okay, the program is working fine. Any questions till now? Okay, so it's time to end the stream now, and we are done with this. Okay, so working with functions, this will be covered tomorrow. So good night everyone, bye bye. So we have covered arrays only today, although we have decided to cover arrays and function both. Only arrays are covered today, so no problem. We will be covering functions tomorrow. We'll be having the stream tomorrow, and let's just end the stream. Bye bye, good night. Revise the concepts, practice the questions, practice more questions on W3 School, or there are lot platforms you can practice and uh, learn more about C programming language. If you are working as a programmer developer, you have to learn more in C programming. You have to go with data structures. But if you are just going with cybersecurity, follow me. You don't need to do extra things. So let's just end the session. Bye bye. Any doubts? If you have any doubts, you can ask. Anything regarding the C programming or anything outside the C programming, you can ask anything. Anything if you want. I think there are no watching is left now. Okay, so let's just end the stream, no problem. So good night.